Welcome, class, to this review session today. Okay, so this is about energy, and we started the unit saying there's really not a great definition of energy. It's the ability to change something or ability to cause change. Most books will say that it's the ability to cause work or the ability to do work, which I don't really like that because then you don't really know what work is. I think a better definition is its ability to do something, cause change, or maybe even to cause pain. We talked about that. You lift something higher up on a shelf, it could then fall and cause more pain. Are you guys secretly laughing on the inside while you're watching me? Is that what's going on? That's what I thought. Okay, the units for energy are joules, capital J. Remember, though, there is a conversion, a rule of thumb that you need to memorize. So the one thing you ought to memorize for the test, 1 calorie, food calorie, is about 4,000 joules. So that when you get an answer in joules, that way you can relate it back to calories and see if it is reasonable. The big idea, I think, of this whole unit, and maybe one of the biggest ideas in all science, is that energy is conserved. And when we say that, we're not using the word conserved in the same sense as when you say, hey, shut off the lights, you need to conserve energy. We're using it in a physics sense that means it's the same before as it is after. Like the total amount doesn't change. So the energy before equals the total energy after in a system. You don't create it, you don't destroy it, you just transfer it around between objects. Now, we use pie charts, and the reason why we use pie charts for this unit was that it helped us keep track of where the energy was at any one moment, and kind of as it transferred around where it went to. So remember, we'd have like a pie chart in the beginning, and then maybe one in the middle, and then maybe one at the end. So at the beginning, maybe you had mostly potential due to gravity with some kinetic, and then maybe it was increasing its kinetic throughout the problem. And then maybe there was some friction or something, and so most of it is kinetic at the end, but maybe you had this slice or chunk of dissipated energy. And remember, dissipated was this category of energy that is heat plus sound, basically. The idea that energy kind of spreads out and becomes less useful. And that's the category of dissipated energy. We had some formulas. You don't have to memorize any of these, but just be familiar with them. Kinetic energy, 1/2 mass times velocity squared. Potential energy due to gravity, mass times the strength of gravity times height. Potential energy elastic. We did that with the pie chart stuff in the beginning. We didn't have a formula for it, but it's the energy stored when something bends or stretches or scrunches up and springs back. And then, of course, the dissipated that I already mentioned. So that was kind of the first half of the unit. And then we, before Christmas and hereafter, have talked about work. That work is the amount of energy that gets transferred. Now, there are other ways to transfer energy besides work, like you can heat something up or radiation, like from a fireplace. But for our purposes, we're only worrying about the energy that's transferred by a force, so by pushing or pulling on something. Work also had a formula, which is force times distance, to figure that out. And since work is really just energy transferred, it still is measured in the same units of joules. Now, the last thing that we had, that we just talked about in the last couple classes, is power. So adding that, power is how quickly energy is transferred. And we said the units for power, watts, which is capital W. 1 watt is a joule of energy being transferred every second. So those are the main details. And thanks for watching.